start recording now, and we'll get started with where we left off. Next week I should be back in person. So this week is one of online now. Okay, cool. All right, let's continue from where we left off. I think this was the question where I left you off last week. You still have the same paper. If you were absent last week, there should be some printed paper outside for you if you were absent last week. So do collect that, yeah? Okay, so let's get started. Hopefully you get to see the screen, yeah? If it is not full screen, please someone just go to the computer and just make it full screen, yeah? Oops, someone is here to do the speaker, I guess. Is that the speaker? All loud and clear? Okay, so you can hear me? All right, let's get started then, guys. So magnesium is a good reducing agent. Can you guys hear me? Is that all right?
Yes.
All right, okay. Magnesium is a good reducing agent. So if you are asked to test for reducing agent, that means you need oxidizing agent. So if you go back to your syllabus, oxidizing agents comes under the redox topic. Okay, so in the redox topic, you need oxidizing agents. In the syllabus, if you go to redox would be, I think, topic 6. There you go, redox. And it says, describe the use of potassium iodide. Potassium iodide is used to test for oxidizing agents because potassium iodide is a reducing agent. Here, what you want is you want to test for reducing agents. You want to test for something metal, which is reducing agent. So what you need is you need oxidizing agent. Acidified potassium manganate is used to test for reducing agents because acidified. Without acidified, your answer will be wrong. Potassium manganate 7. So if you write it in words, you must have the VII. If I write it in formula, is KMnO form, and this is as oxidizing agent. So what happened with this acidified KMnO form as your oxidizing agent is that it will turn from purple to colorless. So this is the answer you're looking for, acidified potassium manganate VII. If they ask you for words, this is what you write. If they ask you for what is the oxidizing agent you can use formulas or you can use words, whichever one is fine. Okay, so I'm just going to go back to the page now, and hopefully you can see that they don't specify name, they don't specify formula. So what you could say, you could use acidified KMnO4. Cannot get the formula wrong. If you use words, you must use every single little bit of the word correct. If you miss one thing, you lost the entire mark, just like that. Okay, so personally, I usually prefer the formula. But then if you write it in words, you must include the VII, that is the manganese plus 7, yeah? The observation is it will turn from purple to colorless. So the purple is the KMnO4, the colorless is the Mn2 plus. So this is Mn2 plus aqueous, and this is MnO4 minus aqueous. And this is straight from practicals or even alternative to practical. They love to ask you the color changes from purple to colorless. MnO4 minus contain transition metal. This is not entirely colorless. Colorless is a bit pale pink, but it's so light in color that it almost appear colorless. Okay, now we're going to move on to the next question. So alkanes are homologous series. You know that what are the characteristics of homologous series? They did say other characteristics because they already talk about one, other physical properties, other, and then the other keyword is physical properties. So not chemical property. You cannot talk about chemical reactivity. You cannot talk about chemical reactions. It has to be about physical properties. So something physical usually refer to melting point or boiling point, states of matter. Yeah. The other one will be density. Sometimes we talk about colors, but colors of alkanes don't really matter. Colors of halogens get darker down the group 7. That is just halogens. Now, they already told you that the boiling point, melting point, and density increase. So boiling point already been used, melting point already been used, density already been used. That is everything I know. But hang on, there is one more. If you think about your fractional distillation assay, the one where you have a fractionating column, the very light one on top, the very light one on top as the fraction that come out first, the very heavy one at the bottom as the fraction that come out last. There is something else called viscosity. Viscosity comes from the English word called viscous. Viscous meaning sticky. Honey is sticky. So honey contains a lot of sugar. Sugar is sticky. So you think about your bitumen, the one that is used to pave road surface, that one is actually quite viscous as a result of, very long carbon chains, very strong intermolecular forces. So they are very much more viscous compared to, I don't know, liquid oil, which is less viscous because it can flow. Now, they want other characteristics. So they already mentioned all the physical properties. So now really your job is to, think about the chemical properties. So what are the characteristics? So each one in the series, they differ by a CH2 unit. So for instance, you will have CH4 methane. So that is called methane. That's the simplest one carbon alkane. And then you have C2H6, that will be ethane. And then you will have propane, which is C3H8, and so on and so forth. So CnH2n plus 2, that is the general formula of alkanes. So what happened then is from here to there, you add 1 carbon, you add 2 hydrogen, so plus CH2. From C2H6 to C3H8, you add 1 carbon and you add 2 hydrogen. So that is plus another CH2. So each one in the series, they differ by CH2. What you can also talk about, they differ by CH2, therefore they differ by 14 MR. Because 12 plus 2 times 1 is 14. So each one will have a difference of 14 in their MR. Hopefully that makes sense, yeah? What other properties I can say? They all have the same general formula. So they all have the same general formula. So in this case, they don't mention alkane. They just say a homologous series. So for instance, for example, alkanes will be CnH2n plus 2, as you would have known that anyway. Excuse me. Now the next question. So it says alkanes undergo combustion and cracking. So both of them, combustion means burn in excess oxygen. Burn in excess oxygen. And when you have excess oxygen, you are going to give carbon dioxide and water. That was something that we did last week. Cracking. Cracking, on the other hand, is break long chain into shorter chain. So you have a very long chain hydrocarbons, very long, not so useful. So what you need is, you need to chop them, you need to cut them into smaller chains. They are more useful. So into more useful, shorter chain. So the long chains become shorter chains. However, this question is asking you of another chemical reaction of alkanes. What we know about alkanes is that if you think about ethane, this is what you call saturated. Saturated because all the carbons is just carbon-carbon single bonds. Carbon-carbon single bond, saturated, cannot undergo addition, cannot do addition. So what they do instead of addition is they will do substitution, where you can replace, substitute means to replace one of the hydrogens with another atom. So this is called substitution. And the reactor we usually use would be things like Cl2, so things like chlorine, and then the condition will be ultraviolet light. So UV light is something you have done in physics. is called ultraviolet light, UV light. Sometimes they can call it sunlight. Sunlight is also ultraviolet light. So what happened then is you have so many hydrogen atoms, you can replace, you can substitute one of the hydrogen with chlorine, and they can ask you, you know, which one? Well, it can be whichever one, doesn't matter because you have so many choices. If I just substitute this one out for chlorine, so this hydrogen comes out and one chlorine comes in to replace that hydrogen. So what happened then is I have one remaining hydrogen and I have one hydrogen. So my other product will be HCl. So make sure you know how to, you know, balance the equation. Substitution reactions, replace one of these hydrogens with chlorine, and then you kick out the hydrogen, you still have another chlorine. So this is a hydrogen chloride. There is no water involved here. This is straight from year 9 structure and bonding. Hydrogen dot cross chlorine. This is a simple covalent molecules with very low boiling and melting point. It's a gas at room temperature and pressure that share electrons. Okay. Now this is cracking alkanes. So long chain hydrocarbons become short chain hydrocarbon. I'll do the next bit first because I want to reinforce the idea. Yeah. So this is long chain C3H28. Now it crack to produce alkene with 4 carbons. The key word there really is alkene. Alkene is CnH2n, and this is n equal to 4, so that is C4H8. And it says one other hydrocarbon only, so no other product, no other product. So I have C13H28. If I have C4H8, what is my remaining carbon? Well, I need to find the difference. 13 minus 4, that gave me 9. And then on my calculator, 28 minus 8, that gave me 20. This is CnH2n plus 2. So this is alkane. And that is fine because hydrocarbons. Hydrocarbons, compounds containing hydrogens and carbon only. So hydrocarbons contains hydrogens and carbons atoms only. So no other elements, no other atoms. It contains hydrogens and carbon atoms only. This is alkanes. This is alkenes. It's perfectly fine. Then one of your other question would be, you know, this question is say construct an equation. They don't say construct the equation. There is more than one possibilities because if this is 4 carbons, but what you could also have is you could have 2 of it. If you have 2 of it, of course, you still have these alkenes, but now you have lesser carbons because there are 8 carbon altogether. So what you're going to get will be 13 minus 8 will be 5. And then this is 8 times 2, which is 16. 28 minus 16, you get 12, which again is also possible because, you know, this is C4H8. You just have 2 of it. You still have hydrocarbon, CnH2n plus 2. So it's entirely feasible. Construct an equation. It's not construct the equation. So there's more than one possibility, but for 1 mark, get straight to the point, save your time. Okay. Now, onto the conditions for cracking alkanes. This is in the syllabus also. Let me try and find it in the syllabus, yeah, because you know you want to see in the syllabus, yeah. Under organic chemistry, where is it? Alkane. I wonder where is it? You see, just now there was that question on viscosity, so that is that. Where is alkane? Draw the structure. Cracking hydrocarbons. Describe the manufacture of alkenes and hydrogen. They don't mention the condition there, but then I'm just gonna write it out. So one thing is high temperature. You do need very, very high temperature as you need to break covalent bonds. You want to shorten the long chain hydrocarbon into shorter chain. Yeah. The other one is you need catalysts. So catalysts help you to speed up the reactions to make it a lot faster. So example would be Al2O3, SiO2. I think just the mention of the term catalyst should be enough to get your marks here. Okay. Everyone okay to continue, or you need some time to copy down the stuff? Okay. All right. Next questions. This one is a 2 marks question. It's just calculating empirical formula. It's a year 9 mole calculation question. First of all, it's a hydrocarbon. So there is hydrogen, there is carbon. Label your working. Empirical formula. It is the simplest whole number ratio of atoms. These are year 9 definition. Yeah, has to be whole number ratio. Sorry, simplest whole number ratio of your atoms. Hence, I write down the atoms. I write down the percentage. This is percentage of carbon. So it's 88.9%. So percentage is out of 100. So if I have this by mass, so that means out of 100 gram is 88.9 gram. That means the remaining percentage, which is 100% minus 88.9, this will give me the remaining percentage by mass of hydrogens. So if you calculate it on your calculator, you get 11.1. These are percentage by mass. I can convert this to gram and gram out of 100 gram. The next thing I do is I work out mole equal to mass over AR. 11.1 divided by 1, because this is about atoms, not about molecules. This is about atoms. So show your working very neatly and very tidily, okay? So you don't want to mess up your working. 88.9 divided by 12, I get 7.4. This is the one thing where people mess up. They run up straight away, and that is wrong. Do not run up straight away. What you need to do is simplest ratio. How in the world do you get the simplest ratio? You need to divide by the smallest number. Divide by smallest number. Your smallest number here is 7.4. So divided by 7.4 on both sides, because you want the simplest whole number ratio. When you do this, you get 1 there. 11.1 divided by 7.4, you get 1.5. Now you have a problem. This is 2 marks. If you stop there, you will realize that 1.5 is not the whole number. 1.5 is not a whole number. From primary school mathematics, 1 over 1 equal to 1. 1 over 2 equal to 0.5. These are some numbers you need to keep an eye out for. Yeah? 1 over 3 equal to 0.33. So, and then 2 over 3 equal to 0.67. When you see these kind of numbers, 0.5 or 0.51, 0.34, 0.32, 0.3, 0.66, 0.68, 0.67, you must think about the number at the bottom. You have to multiply by these numbers in order to get to the simplest whole number ratio. So what I'm going to do is I'm multiply by 2 both sides. 1.5 times 2, I get 3. 1 times 2, I get 2. So now I get the simplest whole number ratio based on the year 9 definition. So this was hydrogen and carbons. So that means I have 3 hydrogens and 2 carbons. So C2H3 is my empirical formula. C2H3 is actually my final answer and not this ridiculous answer CH whatever. You want whole number based on the definition. Everything comes down to the year 9 definition. Okay, everyone all good? Okay, all right, next questions. Now explains why, well, you gotta refer to the equations, why it has both oxidation and reduction. And that is why it's 2 marks. We gotta refer to the equation. We have to refer to the equations, all right? Now, this is what you call zinc. This is not zinc. So be careful. A lot of students, they will say, oh, zinc, zinc, zinc. It's not zinc, it's zinc iodide. It's also mentioned in the question, zinc iodide. And then this one is lithium. This one is not lithium. Okay, basically, the lithium has been converted into a compound. So be very careful about that. Okay, now let's continue on this. So what do we see? The lithium is the metal. It is a more reactive metal than zinc. The more reactive the metal, it can displace, it can kick out, it can reduce the less reactive metal to become the metal itself, extraction of metal. So if you see that lithium, the lithium here is just Li, Li. The lithium here is Li plus, I minus. I hope you can see that because it's already combined with the non-metal, right? So you have Li plus. the lithium become lithium plus. So the lithium metal become lithium plus. So there is a loss of electrons. You have to write the half equations, and we put the electrons on the right because the lithium metal loses electron. And then we balance our equations, one lithium, no charge, +1, cancel out -1. So overall, this equation is balanced. So what can I say? Loss of electrons is oxidation. I mean, that is your oil rig acronym, right? Okay. Now you should be able to do the zinc as well. The zinc iodide, if you know from paper 3 qualitative analysis or paper 4 qualitative analysis, you know that zinc ion exists as Zn2 plus, and I minus, you have 2 of it, and then you get Zni2. So the idea here really is you have Zn2 plus here, and you have Zn on the other side. Zn2 plus becomes Zn, cations, and this is the metal. So you have to gain electrons. When I gain electrons, I put electrons on the left, gaining electrons. Positive charge cation gain electrons. And then this is no charge, so +2 must gain 2 electrons. So that is gain of electrons, which is your reduction. Reduction is gain of electrons. Okay, guys? Okay, on to the next one. This is test for iodide. So if you look in the syllabus printout that I've given you, I think on the first page, on page 2, there is the test for cations, anion, gases. They are all from the practicals, which you are not given. You are not given that table in your paper 4, which you will be taking. You are not given that table. So you need to know the test for iodide. You add some nitric acid, number 1, and then you add some silver nitrate, number 2. And what you will get is, you will get a yellow precipitate because you will form silver iodide. This is all case study, all right? So if I go further down, you have tests for chloride, bromide, iodide. You will get white PPT, you will get cream PPT, and you will get yellow PPT. People remember the results, but people tend to forget the reagents, and you have to fill in the reagent. You have to add HNO3, which is acidified, and then you add silver nitrate. All nitrates are soluble in water, including silver nitrate is soluble in water. Soluble and soluble, these are all aqueous solutions, give you precipitate. In terms of the reactions, you should know Ag plus aqueous plus I minus aqueous, they give you AgI solid. If it is AgCl solid, then it's Cl minus. If it is AgBr solid, it will be Br minus. This reaction is what you call precipitation, because you are forming silver halide, which is insoluble. Silver chloride, silver bromide, silver iodide. They are all from practical studies. Okay. Now the next one, when you have aqueous bromine, this is bromine. So that means this is Br2 aqueous. And then you add it to zinc iodide. This is I minus iodide. You get a brown solution. Name the products. Cannot give formula. If you give formula, you don't get any marks. This is straight from group 7 chemistry. This is called displacement. Displacement in group 7 chemistry. In group 7, you learn that chlorine is above bromine, is above iodine. And you also learn that they become less reactive down group 7. They become less reactive down group 7. The more reactive you are, the higher you are in group 7, you are able to displace, you are able to kick out the halogen below you from the halide. Now, what do we see? Bromine is above iodine. Bromine is above iodine in the periodic table. So as a result, bromine is more reactive than iodine. I know they're not asking for the reason, but sometimes they can ask you for the reason. Because you're above iodine, you're more reactive than iodine. You can kick out, you can displace, okay? The reaction is called displacement. Yes, straight from the syllabus, by the way. They can displace the I2 from I minus. So I minus iodide become I2. You get the brown solution. So that is your aqueous iodine. Aqueous iodine is brown in solution. That's the one you use when you have a cut on your hand or something. You have a wound. You use aqueous iodine as your antiseptic. And when you displace the I2 from I minus, you yourself will get reduced. Then you get zinc bromide. And by the way, this is aqueous zinc bromide. So that and that. How about if we write an equation? I minus ZnI2 plus Br2, then you will get ZnBr2 plus I2. This is very clearly a redox reaction because I minus become I2. It's a loss of electrons, so there's oxidation. Br2 become Br minus, there is a gain of electron, there is your reduction. You can write half equations if you really want to. You should be able to write half equations. Let me just try and write one for you. Okay, like I said, half equation should be pretty easy for you. This is I minus, not I2, because it's in a compound. The I minus become I2. So that is your oxidation. And then your Br2 become Br minus. It's not Br2, it's Br minus, two of them in a compound, ionic compound. And that is your reduction. So that is your redox. And it can happen because bromine is above iodine in the periodic table. Now, this one, why Br2 does not react with chloride? Well, for the same reason. Br2 is below chloride in the periodic table. And if you are below chlorine in the periodic table, Br2 is less reactive than chlorine. If you are less reactive than chlorine, you cannot oxidize the chloride to chlorine because you are a weaker oxidizing agent since you are less reactive. Okay, hopefully that makes sense. Yeah, all good, everyone? Okay, now this next question, this is complete the energy profile. Energy profile diagram has energy on the y-axis and it has progress of reactions. Sometimes they call it reaction coordinates. Reaction coordinate means what happens from reactants to product, A free 2 marks to start off the question. Label reactants, products, enthalpy change. Enthalpy change is from reactants to products, energy level of reactant to product. So they say it's endothermic. Endothermic means delta H is positive. It means you absorb energy from the surrounding. You absorb energy from your surrounding. So that means if this is your reactants, your product will have higher energy because your reactants will absorb energy from the surrounding. So it will look like that. Okay. They haven't asked us to label activation energy. So even if you label activation energy, you don't get extra marks. But I am just going to label activation energy. Activation energy from the energy level of the reactant to the top of the peak. From the start to the top of the peak. That is called activation energy. From the reactants to the product's energy level, that is called enthalpy change. Now you got to label your reactants and your products. Reactants are on the left, products are on the right. So you get 2P plus 3H2, and you get 2PH3 there. And just like that, you get your 2 marks. Okay, happy? All good. Okay, now This is a key essay, right? You might have seen this kind of question always coming out. When I say it's a key essay, you really must know how to tackle this kind of question. Yeah, there are two ways this question can come out. Why this reaction is endothermic, or why this reaction is exothermic. But the first point is the same. The first point is the same. Number one, number two. So your first point really is you must know that bond breaking, the process of bond breaking, you want to break covalent bonds or any bond. Bond breaking is endothermic. You must absorb energy to break bonds. No question asked. When you want to break bond, you must absorb energy. And then the other one is the opposite around. Bond forming or bond making is exothermic. Now there is a calculation, there is a formula. This formula is quite important. Delta H, enthalpy change of a reaction, is the total energy for bond breaking minus bond forming. So this is minus, let me just move that up there a little bit. Total energy for bond breaking minus the total energy for bond forming. So this is minus, yeah, minus total energy for bond forming. So it's the bond breaking minus the bond forming. That will give you enthalpy change of the reaction. If you want your reaction to be endothermic, if you want it to be positive, big minus small will be positive. Big minus small will be positive. Okay? If you want it to be negative, it will be small minus big that will give you negative. Small minus big give you negative. Big minus small give you positive. If you get this formula right, your essay is easy. Now, I want overall to be positive. So overall, endothermic, why is it overall positive? Overall is positive because I have bigger minus smaller. So I have more energy for bond breaking because more energy is absorbed. More energy is absorbed for bond breaking. You see, there are many ways of answering this question. Yeah, you do not have to use my own words. No, you don't. You can use your own words. Okay. Let me tell you, there are two ways of answering this. To make this positive, you can say that the total energy for bond breaking is greater, is bigger, is more than the total energy for bond forming. Or you can say the total energy for bond forming is lesser, it's smaller, it's lesser than the total energy for bond breaking. It's the same thing. Big minus small, or if you say this is smaller than that, that will also give you delta H is greater than 0. As long as you get this formula correct, you will be able to write in your own words. And that's how you get the final marks, okay? I'm just looking at this. So I want to say this is bigger than the other one. So total energy absorbed for bond breaking is more energy is absorbed for bond breaking than total energy release, because I release energy when I form bonds for making bonds or for forming bonds, whichever one you like should be okay. So I'm saying that there is more than one way of answering this essay. Yeah? Do not think that you have to memorize it word by word. No. If you have to memorize something, you need to know the first point is fixed. The second point depends on, do you want the overall to be positive or do you want the overall to be negative? And make sure you get them the correct way around. Yeah. If there's anything you need to know this formula. Total energy for bond breaking minus the total energy for bond forming. Okay, all good, guys? All right. By knowing this formula, then hopefully you can see to get positive, this must be bigger than this. If you want to explain why is it exothermic, exothermic means this is negative. Negative means small minus big. So you will say there will be greater total energy release when you form bond than the energy absorbed for bond breaking. Then overall delta H will be negative and it will be exothermic. Careful with the essay, careful with the actual formula. All right. Now this is balancing equation. You should be able to do this in 1 minute. If you cannot, you would struggle a lot in the real exam. One of the first thing you look for is there is no dotted line here. There is only one molecule of it. So there's 4 phosphorus. So I put 4 phosphorus there because that's the most obvious thing. The next thing is There is no hydrogen. There is no hydrogen. There is 12 hydrogen. 4 times 3, there's 12 hydrogen. There's already 2 hydrogen in water. I just need 6 H2O to give me 6 times 2, which is 12 hydrogen. The next thing is total up the oxygen. So I have 6 times 1, which is 6 oxygen. And then I have 10 oxygen. So altogether, I have 16 oxygen. But this is oxygen molecule. So I need 16 oxygen from oxygen molecule. I need 8. 8 times 2 is 16. And that's how I do it in 1 minute. Okay. Now I'm going to remove all of these. And you're going to balance your own equations. Let me know when you finish. Yeah, I just removed all of that so that you can balance your own equation. All done? If you're finished, continue to the next page. I'm just waiting for people to finish. Come on, balancing equation. For people who are still balancing. Everyone manage your balancing equation already? All good? So your balancing equation should be 4, 8, and 6, yeah? Hopefully you should be able to do that very quickly, okay? Hopefully, all right? Now the next page is starting section B. So, I mean, this is the last week that I'll cover through this paper. So we have around 20 minutes. I'll tell you what, let's go through 2 questions. Whether you guys choose 2 questions. So there's 7, 8, 9, and 10. Choose 2 questions for me and I'll go through 2 questions. Which one do you want me to go through? You gotta shout. The first one you want me to go through, shout, yeah? 7, 8, 9, or 10. I can't hear you at all. It's impossible for me to go through all of them, yeah? You need to choose which one you want me to go through. Yes? Which one? Question 8? Sorry. 10, all right, 10. All right, okay, so question 10. Now this is a table of some group 5 elements. Use information in the table. Now this is a predict and suggest. You are not expected to memorize this value. There is no way you can memorize this kind of thing, right? So what you do is you use the information given. You use the information given. Now it's only 1 mark and 1 mark. They are not meant to trick you for like 10 minutes. No, you're supposed to be able to get it in 1 minute. Now do your normal thing, find the difference. So the difference there is 44 minus, careful, 44 minus 210. So that gives you around 254. And then the difference here is 631 minus 272 is around 359. And give or take, you can see that 600 to 44, that is around 587. So if you split that in 2, so that is 587 divided by 2. Give or take, that's around 293. So what I'm going to do is, there is a difference of 587 between this and this. This is estimate, yeah? Different people will do this differently, okay? I've just, work out the values from my calculator. So the one thing I'll be able to say is maybe 44 plus 293, maybe, okay? I'm not entirely sure. 337 degrees Celsius would have been okay. Am I correct? Hang on. Why is it difficult to predict the melting point of arsenic? They are not asking us for that, apparently. Anyway, let's do the density first. I shouldn't have wasted my time on that. Actually, I work on the density. Okay, 2.34 to 5.73. So they give me 3.39 difference. And then this is very small number. This to this is give or take around 2.3 difference. And then 5 to 9 is around difference of 4. So give or take, you will add another 2, around plus, I don't know, 2.2, 2.3 like that. 5.73 minus 9.8 is 4.07. So maybe plus 2 then instead of plus 2.2. So 5.73 plus 2, 7.73, 7.7 Should be all right. But if you look at the numbers, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, I don't really want to put 7.7. It doesn't quite make sense. Okay. Now I have the unit, gram per cm cube, so I can write down the unit. For the value, suggest why it is difficult to predict. Okay, I get the question now. How come the density we can predict? Increase, increase, increase. All right. Now, in terms of the melting point, if you look at the melting point, it says, why is it hard to predict? When we can predict something, there is a trend. If we cannot find the trend, if there is no trend, if there is an anomaly or something wrong with the trend, we will find it difficult to predict, right? From here to here, increase. From here to here, decrease. So how can you tell whether it's increase or decrease when there is two opposite trends? So that's something that makes it difficult to predict, because no consistent trend, in the melting point. So there's more than one way to answer this question, yeah? So what I have just shown you is there's no consistent trend. You could also say in your own words, you could also say that nitrogen to phosphorus increase melting point. But antimony, I think antimony is SB from your predict table. Antimony to bismuth, decrease melting point. So what we are saying is, you could say this, or you could say the second one. Based on what you could see, it's hard to tell whether it's going to increase or decrease in going from phosphorus to arsenic because of the data given in the table. Hopefully that makes sense, okay? I don't want to make too much of a fuss for these 2 marks. I just want to show you how it's possible to do the questions based on the data given, all right? Now, moving on to the second question, this is where the majority of the marks are. This is all from year 9. This should have been March or April in your year 9 because this is structure and this is bonding. Now they say this one is high melting point. High melting point suggests it's giant. Low melting point, low suggests that, you know, it's simple. Oops, hang on. Low suggests that it has a simple structure. I remember back then, I covered 4 structures with you. They are giant structure, giant ionic, giant covalent, and giant metallic. And there is one simple covalent. Now, when we look at this structure, we have this alternating. You see, this is negative, positive, negative, positive, positive, negative. This is called alternating cations and anion. This is cation. This is anion. This is molecule. This is single molecule. So what we have really is, we have one of these molecule. We can also have another of this molecule. And in between the molecules, we will have weak intermolecular forces. Inter means in between, intermolecular. In between the single molecules, you have weak intermolecular forces. But then inside here, you have strong covalent bonds. Strong covalent bond. But you have low melting point for S. You cannot be breaking the strong one. You have to be breaking the weak intermolecular forces because of the simple covalent structure. Here, this is ionic bond. So this is actually giant ionic lattice structure. Now, so we're going to state in terms of structure and bonding. Do not forget one by one, okay? Compound R. R has giant ionic lattice structure. So number 1, specify 1 out of the 4. Is it giant ionic, giant covalent, giant metallic, or simple covalent? I have just identified 1 out of the 4. Okay. Now that is not good enough. We need to talk about melting. So what does melting involve? Melting is solid to liquid. So melting needs a large amount of energy. How do I know it's large amount of energy? Because of the very high melting point. What do I need to break? That's the question. What do I need to break? What must I break? I need to break strong. Please use the correct adjective. Adjective is very, very important. Strong. ionic bonds. What is ionic bonds? It's the force of attraction between the oppositely charged ions. So this is between the Na plus and the P3 minus. Oppositely charged ions. Ionic lattice, giant ionic lattice. Structure and what are you breaking? Strong or weak? A lot of energy or not a lot of energy? Specify very, very clearly. The next one, S, it has a simple covalent structure. So structure and bonding again, simple covalent structure. So what are we breaking? Melting needs only small amount of energy. I talk about small because little amount of energy, not a lot of energy, Because what are you breaking? Only weak intermolecular forces. We cannot be breaking covalent bond, okay? Covalent bond is strong. Do not go and say covalent bond is weak. Covalent bond is strong. You have weak intermolecular forces of attraction between the molecules. That is weak, and we don't need a lot of energy to break. And just like that, you get your 4 marks. Focus on structure, identify them. And do you need a lot of energy or do you don't need a lot of energy? What are you breaking? Use the correct adjective, strong versus weak. All good? Okay. Now explain why compound R, this was the ionic compound, when molten, liquid. Also when aqueous, yeah? So ionic compound conduct electricity when liquid and aqueous. You go from solid state where you have positive, negative, like that. And then these are tightly packed because they are in the solid state. And they cannot move, they vibrate fixed position. They vibrate about fixed position. The ions are not free to move at all, When you go to liquid, then you have more space in between. When you have more space in between, liquid particles, they can slide past each other. So in the liquid state, what we say is the ions become free to move. The ions are free to move. When you are free to move, you can conduct electricity. Sometimes they call it free ions, not electrons. There is no such thing as electrons in ionic compounds because the electrons already transferred from the metal to the non-metal. Okay. The next one is a molecule of compound S, outer shell electrons, dot and cross. It was given to you as pH like this. Phosphorus 285 electronic configurations. This was your first shell, second shell, third shell, and it's in group 5. So each of these covalent bonds, each of these is a single covalent bond. So phosphorus give 1 electron, hydrogen give 1 electron. So they share 1 covalent bond. The second one, dot cross hydrogen. The third one, dot cross hydrogen. So cross, cross, cross. If I have 5, but then I only use 1, 2, 3 for forming covalent bond. I have 5 in my outer shell. I only form 1, 2, and 3. I only use 1, 2, and 3. I still have 2 more. Do not forget to count 1, 2, 3, 4, 5. 5 crosses, 5 outer shell electrons of phosphorus. Hydrogen share 1, 2, and 3. 3 covalent bond, just like that. If you want, you can draw shell. Whether you draw the shell or not, it shouldn't affect the understanding of how many electrons is in the covalent bond to begin with. Okay, and that's just it for 1 month. If you spend more than 1 minute on this, you know you'll be wasting a lot of time, yeah? Okay, just so you know. Make sure you know how to translate diagram like this into your dot and cross. Okay, 1 minute is all you have. Now, last but not least, this is a 2 marks calculation. This is under year 9 mole calculation. Percentage by mass. Just now when we work out empirical formula, we use percentage by mass to get formula. Here they give you the formula. To work out the percentage by mass, you need to first work out the MR. You need the MR first of all. So if you look at the predict table, 4 times 31 plus 16 times 10, you should be able to press your calculator on your own. And I get 284. There's the first step. It means out of 284, how much is phosphorus? This is percentage by mass of phosphorus. Out of 284, out of 284, how much of the mass is contributed by phosphorus? I have 4 phosphorus, 4 times 31. So 4 times 31. That is the mass of the phosphorus. This is the mass of the phosphorus oxide. And then I find 100%. Out of the 284, how many percent is the mass made up of phosphorus? So 43.66, I will give that to 43.7%, as or initially I have used 1, 2, and 3. So based on my data, I will write it up to 3 significant figures for my final 2 marks. Okay? All right, we probably have time to do another question, but I wouldn't be able to finish it. So what do you guys tell me which question you want me to go through? Not much time left. All right, question 8, molecular formula. Molecular formula is defined in year 9 as the actual number. So when you count all the atoms, it's the actual number of atoms in one molecule. In one molecule. Okay, that is year 9 definition. This is one molecule of it. It's a simple covalent structure. Then you count how many carbons. 1, 2, 3. Then you count how many hydrogens. 1, 2, 3, 4, 5, 6. Then you count how many oxygen. 1. There you go. You get 1 mark. Actual number of atoms in one single molecule. Can you simplify it any further? You cannot. So the empirical formula is the same as the molecular formula because you cannot simplify it any further. Now, compound T is a colorless liquid. What does it have? It has alkene. It has alcohol. These are 2 different topics from your organic chemistry. Aqueous bromine. Aqueous bromine is Br2, aqueous. It's also known as bromine water. Sometimes we say we can add bromine water. Bromine water means bromine dissolved in water. And this is orange yellow. It's not bromine liquid. Careful, yeah? Bromine liquid is an element. It's reddish brown liquid. But then when it dissolves in water, then you're going to get very dilute color, which is orange yellow, no longer very concentrated in color. And we use bromine. Bromine can add onto the double bond. Alkane is saturated. Alkanes undergo substitution. That was what we talked about earlier, UV light. This is alkene. Alkene is unsaturated. Unsaturated means it's not yet carbon forming, like completely full, because I can still add onto the double bond. Therefore, alkene can undergo addition reaction. And this one will become colorless. We use aqueous bromine to test for alkene because alkene will decolorize. It will turn aqueous bromine from being colored to colorless. Whereas alkanes already saturated will have no reactions with bromine, water, and therefore it will just remain orange yellow. If you have alkanes, it will remain your orange yellow. Okay. Now this next one is something we have done earlier. You want an oxidizing agent. I hope you remember the first thing we did just now. You want an oxidizing agent. It's from the redox topic. Do you remember what you need to write down? Oxidizing agent. Straight from the syllabus. You can look in the front page. The first question we went through today at the beginning. Straight from the syllabus under redox topic. Not the first question, but the first question we went through today. You needed an oxidizing agent to test for reducing agent right just now, right? Earlier, you had this question where you wanted to test for reducing agent. So you use oxidizing agent. You use acidified KMnO4, or you say acidified potassium manganese 7, that is in words. It's the same oxidizing agent in your syllabus. Make sure you do not forget oxidizing and reducing agents, okay? They often comes out, yeah? So there you go, okay? So if you use it in words, make sure you write it in full, okay? Potassium manganate 7. Last but not least, polymerization. I think we have time up until this question only. So here, when you polymerize this, look for where the double bond is. Look for where the double bond is, okay? Draw the carbon-carbons. Do not draw the double bond. Now you put in all the other atoms. The HH on top, and then the H and CH2OH at the bottom. The H and the CH2OH at the bottom. This was the original carbon-carbon of the double bond. We do not change anything, but now the carbon, you see, this carbon, 1, 2, and 3. This carbon, 1, 2, and 3. Not happy, not happy. Carbon form 4 covalent bond. Must show open. Okay? Now this is your, hang on. This is your 1 repeat unit. This is 1 repeat unit. So now the carbon form 4 covalent bonds. No more double bond because it's part of polymer, but they want 2 repeat units. If they want 2 repeat units, well, just draw another one. Okay, I can do it on my screen easily, but then you should be able to, you know, show it very easily on your paper as well. So carbon there form 4 covalent bond, 4 covalent bond. It must show the open chain. Yeah, if you don't have open chains, your carbon don't form 4 covalent bond, then you are done. You are screwed. Okay, polymer, no more double bond. It is called addition polymerization. Addition polymer. Why is it addition polymer? Because you add onto the double bond. You add onto the carbon-carbon double bond. Alkenes undergo addition reactions. Okay, I think that's all the time we have for today. But since the other teacher hasn't come in yet, I'll probably, I think one of you maybe need to open the door because otherwise the other teacher might not know that the session has finished, to be honest. Okay, we'll just leave it there for today. So can someone just open the door and get someone from Alaf? So guys, do continue the rest of the paper. You need to finish off. You should be able to finish off the rest of it now. And I'll see you in person next week, and we'll go through another paper. Yeah. If you want, I can continue more of this paper next week. But I'll print you another new paper to do next week. Okay. So just try and finish off the rest of this paper. If you have specific paper that you wish for me to go through, then just mention in the Google Classroom or just text me, and I'll ask Alaf to print it out. Okay, it's really up to you guys. All right, I should be back in person next week, so see you guys next week. Yeah. Can someone get the Alaf people, because this computer needs to go to the other room now because I am not in person.